Why does the moon smell like gunpowder? That's the strange report astronauts gave after their historic Apollo missions. Imagine stepping onto an alien world, collecting dust from its surface, and then bringing it inside your spacecraft, only to be greeted by a smell that reminds you of fireworks or a spent cartridge at a firing range. It sounds impossible. After all, the moon has no air, no atmosphere, no fire, no chemistry that should produce such a scent. Yet multiple astronauts insisted. Lunar dust once inside the cabin gave off a sharp, burnt smell. How can something that has never touched oxygen smell like burning? Let's dig into this cosmic mystery. First, picture lunar dust itself. On Earth, when you think of dust, you imagine soft powder like talcum or flour. But lunar dust is nothing like that. The moon has no wind, no rain, no rivers to tumble and smooth its particles. Instead, every grain of lunar soil, called regolith, has been shattered and ground by billions of years of meteorite impacts and cosmic radiation. That means each particle is jagged, sharp, and reactive. Imagine smashing glass with a hammer until it becomes sand. Those shards don't round out naturally. They remain edged, splintered, and aggressive. Lunar dust is like that. Tiny knives, billions of them clinging to everything they touch. Apollo astronauts described it as sticking to suits, boots, and tools with static cling so strong it was almost impossible to brush off. Once they brought it inside the lunar module, they found it everywhere, floating in the air, coating their gloves, sticking to filters. And that's when the smell emerged. Here's the paradox. On the moon, there's no atmosphere. The dust is completely inert, at least in terms of smell. You can't smell anything in a vacuum. But once inside the module, exposed to oxygen-rich air for the first time in billions of years, something dramatic happened. The sharp, freshly fractured surfaces of the dust particles began reacting with oxygen. It's like striking a match. The reaction didn't create flames, but it produced volatile molecules that our noses interpret as burnt, metallic, or sulfur-like. That's why astronauts compared it to gunpowder. Not because it was explosive, but because our sensory system linked those reactive compounds to the same signature we know from combustion. To grasp this better, let's use an analogy. Imagine cutting into a fresh apple. The moment you slice it, the inside begins to oxidize, turning brown. You can smell that change. It's crisp, slightly sharp. Now scale that idea up to dust that has been untouched for billions of years. Those jagged lunar grains are like apples waiting to be sliced. When they finally meet oxygen inside a spacecraft, they brown instantly, chemically speaking. The smell is the signature of that sudden interaction. But there's another twist. Lunar dust is rich in unusual minerals and tiny glassy beads formed by the intense heat of meteorite impacts. These materials hold energy in their structure, and some even trap solar wind particles, like hydrogen and helium, bombarding the moon's surface. When disturbed and brought into oxygen, these trapped elements may release subtle reactions that further add to the strange scent. It's like opening a long sealed jar and finding it suddenly fizzing with hidden energy. Now here's the wow moment. The moon doesn't just look alien, it smells alien too. Yet the human brain processes that smell using familiar categories, so astronauts could only compare it to the closest earthly analog, spent gunpowder. The reality is, it wasn't gunpowder at all. It was the nose interpreting a brand new chemical cocktail through an old sensory library. Let's add another layer. Scientists back on Earth tried to replicate the smell of lunar dust by opening sealed containers of returned samples. But here's the surprise. They couldn't reproduce the same gunpowder odor. Why? Because the moment lunar dust samples touched Earth's atmosphere and humidity, they began to lose their freshly reactive surfaces. They no longer had the same instant oxidation effect astronauts encountered in the closed cabin. In other words, the smell of the moon is something you can only experience there, in the moment, as dust first touches oxygen. It's a fleeting signature, like a firework that flares and vanishes. This makes it one of the rarest scents in the universe. Think about that. Out of all the billions of people who have lived on Earth, only a handful of Apollo astronauts ever smelled the moon. And what they described wasn't flowery or sweet or otherworldly. It was gritty, industrial, metallic, almost violent. A reminder that the moon is not gentle but raw and sharp. This also shows us something deeper, the way our senses interpret alien environments. The human nose evolved to detect danger, spoilage, and fire. When faced with lunar dust, it fell back on familiar categories, labeling it burnt. But the real story is chemistry, not combustion. That's what makes this mystery so fascinating. A simple sensory report, "It smells like gunpowder," unlocks a tale about the moon's history, its lack of atmosphere, the violence of meteorite impacts, and the razor-edged dust waiting for oxygen to wake it up. Now let's connect this to something more familiar. Have you ever noticed how rain has a smell? That earthy, fresh aroma before a storm is caused by geosmin, a compound released from soil when water hits it. The smell isn't the rain itself, but the interaction between rain and Earth's chemistry. The moon is similar. The smell isn't the dust itself, it's what happens when dust meets oxygen in a closed environment. A smell is not a thing. It's a story told by molecules, and the moon story, at least to our noses, sounds like gunpowder. Imagine this scene. An astronaut, suit covered in clingy gray dust, climbs back into the lunar module. He removes his helmet, breathes in, and says, "It smells like fireworks in here." That sentence, simple as it is, carries within it the tale of billions of years of cosmic history, impacts, solar radiation, vacuum silence, all distilled into a fleeting aroma. And now, when you hear "the moon smells like gunpowder," you'll know it's not just a quirky astronaut anecdote. It's a reminder of how alien environments interact with human senses in surprising ways, and how even something as ordinary as smell can unlock extraordinary science. The lunar surface is not alive, not fertile, but it still tells a story the moment it touches us. It's almost poetic. The moon has been silent for eons, but when humanity finally visited, it spoke in the language of scent. And that scent was one we associate with power, danger, and transformation. That's the beauty of science. It takes a fleeting report, a smell in a cabin, and unpacks a chain of physics, chemistry, and sensory biology that explains it. It transforms mystery into clarity, confusion into awe, and yet the awe remains. Because knowing why the moon smells like gunpowder doesn't make it less magical, it makes it even more astonishing. Think about what this tells us about the moon itself. Its surface is not just dusty, but chemically restless. Billions of years of bombardment by tiny micrometeorites and streams of solar wind have charged and fractured every grain. On Earth, weather would have worn these sharp edges down. Rain would have washed them. Air would have oxidized them. Time would have softened them. But on the moon, there is no weather, no air, no protective blanket. Every grain of dust is a fresh scar from cosmic violence, still holding its energy. When astronauts scooped it up, they weren't just collecting dirt. They were gathering fragments of time, samples of an untouched world. And when that dust met oxygen for the first time inside the module, it spoke, not with light or sound, but with scent. That is what makes this mystery so haunting. The moon has been silent for billions of years, and yet in that moment, it seemed to whisper through the noses of astronauts. The smell of gunpowder was like the aftertaste of cosmic history, the echo of meteorites and radiation preserved in grains of regolith. It's a reminder that sensory experiences, what we smell, touch, or see, are not random. They're data. A smell is chemistry translated by our brain into meaning, and sometimes that meaning can trick us. To the astronauts, it felt familiar, like spent fireworks. But in truth, it was something far stranger. Oxygen rushing into reactions with minerals that had been waiting in silence since the birth of the solar system. To make this clearer, imagine you've kept a piece of iron sealed in a vacuum for billions of years. It looks stable, unchanged. But the moment you expose it to air, it starts rusting. The change is immediate and obvious. Lunar dust works the same way, but instead of red rust, it releases invisible molecules that smell sharp and metallic. That instant burst of chemistry is the moon's version of rust in your nose. Another analogy, picture opening a brand new electronics package. That smell of newness comes from fresh plastic compounds meeting air for the first time. Now scale that up to a planetary level and swap plastic for crushed rock infused with solar radiation. The result is the moon's scent, strange, fleeting, unforgettable. Scientists are still fascinated by this. They want to understand what compounds actually caused that smell. But here's the frustrating part. Because lunar samples brought back to Earth were exposed to moisture and air, their surfaces quickly changed. By the time researchers opened containers, the gunpowder smell was gone. Like a firework fading in the sky, it could never be captured again. That makes the smell of the moon one of the rarest human experiences in history. Fewer than a dozen people have ever inhaled it directly, and no one else ever will, at least until we return. It's like a sensory relic, a fleeting memory stored in the accounts of Apollo astronauts. But let's step back and think about the bigger picture. What does it mean that the moon smells like gunpowder? It means that space exploration is not just about distant stars and abstract science. It's about bringing alien environments into direct contact with our human senses. It's about finding poetry in the unexpected. The moon didn't need to be alive to surprise us. It only needed to be different enough to force our brains into making new connections. And in that sense, the moon's smell wasn't just a chemical reaction. It was a story about perception, about how humans translate the universe through the filters of biology and memory. There's a practical side too. Understanding lunar dust is crucial for future missions. That clingy, reactive powder could damage lungs, scratch equipment, clog filters, and wear down spacesuits. The very same qualities that made it smell like gunpowder could also make it dangerous for colonists or astronauts living on the moon for long periods. So studying this strange aroma isn't just trivia, it's essential preparation. But beyond the risks, there's wonder. Because what strikes me most is how the smallest detail, a smell, can open up vast insights into geology, chemistry, and human perception. Science often hides in the little things, waiting for us to notice. And that's why this story resonates. It shows how something as ordinary as, "What does it smell like?" can unlock an extraordinary truth about how our world and the moon are fundamentally different. Imagine then, how many other secrets are waiting on Mars, on asteroids, or on the icy moons of Jupiter? What will Europa smell like when its ice first meets oxygen? What scent will Mars dust carry into a habitat? These questions remind us that exploration is not just about seeing or measuring, it's about experiencing. And that is where awe is born. The smell of the moon is proof that the universe always has surprises left for us, even in places we think we know. We look at the moon every night, but only a handful of humans discovered that up close it has a scent. Not a scent of flowers or forests, but the scent of something raw and elemental. The smell of cosmic dust waking up to air. So the next time you see the moon rising, imagine it not just as a silent light in the sky, but as a world that once spoke to a few lucky astronauts through the most unexpected channel, through their noses. And let that thought remind you that science is about curiosity in every form, even in smells. Because if the moon can smell like fireworks, then the universe is far stranger, richer, and more intimate than we ever imagined. And that's why we keep exploring. That's why we keep asking questions. And if this story sparked your curiosity, if it made you see the moon in a new way, then you're exactly where you should be. Here, on How It Actually Works, where we collect keys to unlock the hidden layers of reality. So give this video a like, share it with someone who's ever wondered what the moon is really like, and subscribe. Together, we'll keep turning cosmic mysteries into moments of clarity and wonder.